Okay, we're going to start a new unit. Unit 4 is going to be more trigonometry. We're going to use a lot of the ideas we did last unit. Day 1 is going to be investigating inverse trigonometry. So we're going to have to start thinking in reverse. So we're going to look at two functions. F of x equals sine of x, and this other one that says g of x equals the inverse sine of x. Do not call this sine raised to the negative 1. It's inverse sine of x. So our first question is, what do we get when f of x is equal to a half, or better yet, sine of x is equal to half? Well, this is kind of what I made you did on homework 28 that was due, is we're looking at sine of x is equal to a half. And the idea is that this half is output. And we're trying to find what input, or specifically what angle do we have for x to make sine equal to half. And we're only going to do this on one unit circle. One time they're around the unit circle from 0 to 2 pi. So if we look at what we did for our homework, we got two results for x. X equals pi over 6 in quadrant 1, and x equals 5 pi over 6 in quadrant 2. That's because this x is input. And when we did this on one unit circle, we got two solutions. Well, what would have happened if I would have done this on all real numbers? In other words, on more than one unit circle. If I would have kept on going around and around and around and around, I would have got infinite solutions. Many, many, many. So now we're going to think in reverse a little bit. So the question is now, instead of doing with f of x equals sine of x, let's do the inverse function. So if we do it the other way around, I'm saying g of 1/2 is equal to inverse sine of a half. Not because I switch things around. This half is still input, and I only can get for function one result. So inverse sine of a half is equal to half, because I can only have one result to be a function. Okay, inverse sine of a half isn't multiple answers. It can't be pi over 6, 5 pi over 6, and other things. It only could be pi over 6. It has to be a function. One. I only have one. For every input, there's exactly one output. Okay, let me put this. This is my one output. So what's going to have to happen is that we're going to have to, when we compare A and B, we need to restrict the domain of the sine function in order for the inverse to also be a function. Okay, so let's look at things graphically first. Over here, I hope you recognize that we have y equals the sine of x. The domain for this function is all real numbers. It goes on forever, and the range is from -1 to 1 inclusive. Now in the second part, I'm going to draw the inverse by switching x's and y's. I'm going to switch x's and y's. I'm going to do that off camera. So you could tell I drew the inverse over here by switching x's and y's, and you could tell it's not a function because it does not pass the vertical line test. So if I went right now and looked at this, saying this graph is y equals the inverse sine of x, not only do x's and y's have to switch, domain and range have to switch. So my domain is -1 to 1, which is a good thing. But my range right now is all real numbers, -infinity to infinity. That's not good. That's what makes it not a function. So what I need to do is find one piece of this from -1 to 1 for my domain, and I'm going to use this piece right here. If you notice, this piece right here gets all the -1 to 1 for the inverse, and then that's just a function, so I've restricted my domain. So my restricted domain I mean my restricted range, my bad. My restricted range is from negative pi over 2 to pi over 2. And that's what we're going to look at. I'm going to show you I have to restrict my domain to negative pi over 2 to pi over 2. Okay? Even so it seems weird to grab negatives, that's what we're going to do. Now I'm going to touch these little globes. They're going to send us to a link, and you're going to see what I mean, what the function and what the inverse looks like. So I'm going to show you the graph of sine by checking the box. And there's a sine graph. And another word for inverse sine is called arc sine. We'll talk about that in a minute. And we'll look like that. And you can see it is not a function when I do all that. Okay, so we had to restrict what we're doing. So I click on that other little globe by it, and I'm going to again do the sine function. And now you can see its domain is all real numbers, its range is -1 to 1. Now I do its inverse, and this is what we get. We only get this little part right here in purple as inverse sine, and it's also restricted the original function to show you that I don't need the whole function, because if I take the inverse of the whole function, the inverse will not be a function. So the question is, what quadrant should I use of the unit circle for inverse sine? Well, I'm using from negative pi over 2 to pi over 2. So if I draw a unit circle over here, I'm not going to draw the whole unit circle. I'm only going to draw part of it. And I know this angle up here is pi over 2. This is 0. And normally I call this one 3 pi over 2, but that's if I go the long way around the circle. If I go in reverse, this angle is really negative pi over 2. So I'm using quadrant 1 and quadrant 4. Over here, these are the positive values, and over here, these are the negative values, because in quadrant 1, sine of x is equal to a positive, and in quadrant 4, sine of x is equal to negative, and therefore I get all the numerical values that I want. So I'm using quadrant 4 connected to quadrant 1 by going from negative pi over 2 to 0 to pi over 2. And my theta would be these angles from negative pi over 2 to positive pi over 2. And this is quadrant 4 to quadrant 1. It's a little bit different, but we'll get through some examples and you'll see how easy it really is. Okay, we're going to do the same thing for the cosine graph. Here's my cosine graph. And its domain is all real numbers, because it goes on forever. And its range is, again, -1 to 1. Now I'm going to switch my x's and y's, and I'm going to draw its inverse. I'm going to do that off camera. Okay, so you see I draw the inverse by switching x's and y's. You can see it's not a function again. So we're going to have y equals the inverse cosine function. And I have to switch domain and ranges, where my domain is going to be -1 to 1, which is what I like. But my range right now is all real numbers, -infinity to infinity, which is too much. So I have to figure out where I can just capture -1 to 1 on the domain and just make it a function. And it's going to be this part right here. This part of this graph right here is very special. Okay. It's not a function because it does not pass the VLT. So this little part that's restricted, my range is going to be from 0 through pi. Angle 0 through pi will capture all the cosine values from -1 to +1. So my domain restriction from the cosine function would be 0 through pi. Again, I'm going to hit my little globes to show you what these functions look like. Okay, back to GeoGebra. Here's the cosine function, all the little waves. And arc cosine is the inverse cosine. You can see the light blue is definitely not a function. So what do we have to do? We're going to the other one. I could turn these off. I'm going to hit the cosine function. And there's the cosine function the way that we're used to. And you can see the domain is all real numbers, and my output is -1 to 1. And when I do the inverse, I only get that little part of it where my domain is -1 to 1, and my range, or my output, which is what I really want, is 0 through pi. So what quadrants do I want for the unit circle for the inverse cosine function? I'm going to draw my little unit circle here. And I'm going to use this part. And I have quadrant 1 and I have quadrant 2 because in quadrant 1 these are all the positive values for cosine. In quadrant 2 these are all the negative values for cosine. This is 0. This is pi. Up here is, I'm going to have to squeeze it in, pi over 2. In quadrant 1 cosine is equal to a positive value, and in quadrant 2 cosine is equal to a negative value. So I'm doing quadrant 1 connected to quadrant 2, which is my angle is from 0 through pi radians, because I'm going to speak radians, and this is quadrant 1 to quadrant 2. Now we're going to do a graph that we haven't done before. We're going to graph tangent on negative 2 pi to 2 pi. We've never done this before. The one thing I know is for tangent is that I have asymptotes at, well, let's see. This is pi, this is negative pi. So right in the middle here at pi over 2, I have a vertical asymptote, and at negative pi over 2, I have another vertical asymptote. And in the middle here, I have another asymptote. And over here in the middle, I have another asymptote. So I have all these VAs. This is negative 3 pi over 2. This is negative pi over 2. This is pi over 2. This is 3 pi over 2. These are all the VAs. So what does the graph look like? Well, I know tangent of 0 is equal to 0. And tangent of pi over 4 is equal to 1. And I think tangent is odd. So I kind of get this squiggly little graph that kind of looks like an x cubed. I get it again. I get it again. And so on and so forth. And that's what tangent graph looks like. I'm not going to ask you to graph it ever. So now I'm going to do the inverse by switching x and y's. I'm going to go off camera to do this. Okay, so going back to this is the graph for y equals tangent of x. Its domain is all real numbers except the VAs, and my range is still all real numbers. I have everything there. This graph is not a function because it doesn't pass the vertical line test, so I just need to capture one little piece of it. I'm going to capture the one in the middle, right here. Just like that. And this is y equals the inverse tangent of x. And normally you would think switching them that my domain will be all real numbers, which is fine, and my range should be all real numbers except the VAs. But I don't want that. I have to restrict it a little bit. So I'm going to restrict it to this one in the middle, and this is negative pi over 2 to pi over 2. So my restriction for my range will be negative pi over 2 to pi over 2. Notice I'm going to use parentheses this time based on those values are asymptotes. So my domain will be negative pi over 2 to pi over 2 because I had VAs at x equals negative pi over 2 and pi over 2, and I cannot include those in what I do. So I'm going to hit those little globes again, and we're going to go through those graphs. Okay, this is a graph we just did tangent. I'm going to make you graph it. You know, so the little squiggly little x cube graphs look very weird, and here's what its arctangent or inverse would look like. Obviously, those yellow ones would not be functions. So what does it look like when we make it into a function? Well, here's the tangent function again. All those little squiggles. You see you have asymptotes at negative pi over 2 and positive pi over 2. And here's its inverse, and it just really uses that one little piece. And inverse tangent, their domain is all real numbers, but its output or range is negative pi over 2 to pi over 2, not including them. So again, the question is, what quadrant should I use for inverse tangent? Well, I'm going to draw my little unit circle, and I'm going to pick these two. And this is pi over 2, this is negative pi over 2, This is 0, and these are positive, and these are negatives. So when I'm in quadrant 1, my tangent is equal to positive values. When I'm in quadrant 4, my tangent are equal to negatives. And some people say, well, why don't we use quadrant 2? Tangent is also negative there. Well, the problem is that quadrant 1 to quadrant 2 is not continuous. You have an asymptote in the middle at pi over 2. So it makes more sense to use quadrant 4 connected to quadrant 1. And we're going to use our angles, negative pi over 2 to pi over 2, because on that part of the graph, you can see it's a nice continuous graph. And that's quadrant 4 to quadrant 1. And if you look carefully, it is just like the inverse sine that we did earlier. Inverse sine and inverse tangent will have very similar, we'll use the same quadrants to figure out results. So here's a little summary. In quadrant 1, everything is positive. In quadrant 4, I have inverse sine and inverse tangent that are negatives. And quadrant 2 is going to be inverse cosine is negative. So I'm going to use this part first. I'll do this in blue. The blue is for inverse sine and inverse tangent. Okay? It uses quadrant 4 connected to quadrant 1 from negative pi over 2 to pi over 2. Quadrant 4 is just the negative of quadrant 1 when you go in reverse. And this is actually going to be the easier one to do. Much easier, because when we're in quadrant 1, we have positive numbers, and we also have positive angles. And all the angles will look like pi over denominator. When we're in quadrant, I'll keep it blue. When we're in quadrant 4, we have negative numbers, and we're going to have negative angles, and those angles will look like negative pi over a denominator. Okay, notice this angle down here is not 3 pi over 2, it's negative pi over 2 because we will make it continuous. Negative pi over 2 to negative pi over 4 to 0 all the way up to pi over 2. I'm going to do the one in red. So the red will be the inverse cosine that uses quadrant 1 and quadrant 2. So inverse cosine uses quadrant 1 connected to quadrant 2. Okay, quadrant 1, again, will be positive numbers, and we'll have positive angles that all look like a pi over denominator. And in quadrant 2, we're going to have negative numbers for cosine. Still positive angles, because that's what the angles are, but these angles are going to look like a numerator times pi over the denominator, where the numerator is 1 less than the denominator. We've talked about this earlier. So this is kind of the way I look at things. We'll get through examples in a minute. Now for vocabulary, I've already mentioned it briefly, that inverse sine and arc sine mean exactly the same thing. Okay, in fact, I'm old enough to realize that I never used inverse sine, I used arc sine. So when we do this question, which we did on the front page, it says inverse sine of 1/2 is equal to pi over 6. If I ask arc sine of 1/2, the answer is still pi over 6. Because what is it really asking? This is really asking, give me an arc or an arc length whose sine value is equal to 1/2. And when I say arc, an arc is really an angle theta that we're looking for. Because that's what we said radians were. They were arc lengths on the circle. So in summary, when we do trigonometry, our input is an angle, our result is a ratio or some number. Okay? This is a theta, this is a number. Now when we do inverse trig, it's the other way around. Things get switched. Then when we do inverse trig, that this is a number, and what we're looking for is an angle theta. So when I do sines of angles, I get numbers such as sine of an angle pi over 6 is equal to 1/2, or cosine of pi over 4 is equal to radical 2 over 2, or tangent of pi over 4 is equal to 1. This is what I mean. Pi over 6 is an angle theta. 1/2 is a number or a ratio. Pi over 4 is an angle. Radical 2 over 2 is a number. Pi over 4 is an angle. 1 is just a number. That's when we do trigonometry. When we do inverse trig, it works the other way around. I do inverse sine of 1/2, I get pi over 6. Or I do inverse cosine of 0, and I get an angle of pi over 2. Or I do inverse tangent of 1, and I get an angle of pi over 4. That's a number, and my result is an angle theta. Number, angle theta. Number, angle theta. So when we do inverse trig, inside the parentheses is a number, like 1 or 0 or radical 2 over 2, and our result is always an angle. Always, always, always. Okay, I'm going to complete this unit circle to what I need for inverse trigonometry. Notice I do not use quadrant 3 at all. Okay? I use quadrant 1, quadrant 2, and quadrant 4, but quadrant 4 is a little bit different. So I'm going to put in all the x values for cosine and all the y values for sine for all the points on these unit circle. I'm going to do that off camera. So I'm going to do the same thing for tangent. I'm going to do it in pink. So tangent is sine over cosine, or y over x is the slope. So these slopes here are 0. This one in the middle is 1. This one over here at the top is undefined. In the middle here, this is 1 over radical 3, or radical 3 over 3. And this one here is just radical 3. I haven't done the other quadrants yet. I will in a second. So right now, excuse me, right now I'm just playing with quadrant 1. And everything in quadrant 1 is positive, so I'm going to use inverse cosine, inverse sine, inverse tangent when I have positive numbers. We haven't talked about them yet, but we will talk about how we're going to do inverse secant, inverse cosecant, and inverse cotangent. Again, they're all, when I have a positive number, it's all going to come from quadrant 1. Now, I'm going to fill in quadrant 2 and quadrant 4 for the x and y values. I'm going to do something a little bit different. Okay, I filled in quadrant 2 the ordered pairs and quadrant 4, but notice in quadrant 2 I only filled in the x values because they're negative. The y values are positive. I don't need those again. I already have them in quadrant 1. And in quadrant 4 I did the same thing. I only filled in the y values for the ordered pairs because I only need the negative y values because the positive x values I've already done. I didn't fill in for the negative tangents in pink because I do need negative tangents. So I can say when I'm in quadrant 4 I need to use some negative things. And the things that are negative are going to be inverse sine. Let me get out of here. Inverse sine, inverse tangent, and then I'm also going to use inverse cosecant. Now when I'm in quadrant 2, the things that are negative I'm going to use is inverse cosine, which means I'm going to use inverse secant. And here's a weird one, is inverse cotangent I'm going to use. Why wouldn't cotangent go with tangent? That's because cotangent's graph has an asymptote at 0, because that's where tangent is equal to 0. So from 0 through pi it is continuous. I'm not going to ask you too many inverse cotangents, so I won't worry about it. But this is a picture I have. Now if I look carefully at the angles, when I'm in quadrant 1, my every angle here is pi over denominator. Every single angle looks that way. When I'm in quadrant 4, it looks exactly the same as quadrant 1, but it's going to be negative pi over denominator. So quadrant 4 is really, really easy. They're just the negative angles, the negative y values, and the negative tangent values of quadrant 1. Exactly the same. And when I'm in quadrant 2, I have a numerator times pi over the denominator, and my numerator is always 1 less than the denominator. That's how I remember my quadrant 2. Again, I didn't use anything in quadrant 3. So now we're going to go through some examples. So basically all these questions I'm going to ask, what kind of number do I have? Positive or negative? If the number is positive, the angle's in quadrant 1. If the number is negative, it's going to be in a different quadrant. For sine, inverse sine, and inverse tangent, it'll be in quadrant 4, but it's super easy because it's just negative. When it's cosine, it's going to be in quadrant 2, and I have to figure out what angle's in quadrant 2. So this first one, positive number, I'm in quadrant 1, and sine, inverse sine of 1 is equal to a half, because that's what angle I have to be at to get the y value equal to 1. Well, now, with a negative number, that means I have to go to quadrant 4, and that's just going to be negative pi over 2. That's how easy it is. Negative number just makes a negative angle for inverse sine. Positive angles, quadrant 1. When does sine equal radical 3 over 2? That is pi over 3. Now that I have a negative angle, it's going to be in quadrant 4, and it's going to be exactly the same thing I got for that last problem, except it's going to be negative pi over 3. That is how easy it is for inverse sine. When does sine, and again I said the word arc sine, inverse sine and arc sine mean the same thing. So arc sine of 0, well, that angle is 0. And arc sine of negative radical 2 over 2, well, negative number means I'm in quadrant 4. Normally it would be positive pi over 4 to get radical 2 over 2, but since it's in quadrant 4, it's just going to be negative pi over 4. That's how easy it is. Now for cosine, positive numbers, quadrant 1. When does cosine equal 1? At 0. Arc cosine of negative 1, well, now I have to go to quadrant 2, and that's on the other part of the circle, and that's going to be the angle pi. Arc cosine, positive numbers, quadrant 1. When does cosine equal radical 2 over 2? That's at pi over 4. Now I have a negative number, so it has to be in quadrant 2. And it's still got to be something pi over 4, but when I'm in quadrant 2, the numerator is 1 less, 3 pi over 4. Positive numbers in quadrant 1. This is pi over 3. Inverse cosine of a negative number, I'm in quadrant 2, but it's still a half, so it has to be something pi over 3. But because it's in quadrant 2, it's 2 pi over 3. Like I said, that's how easy it really is. For tangent, when does tangent equal 1? In quadrant 1, that's pi over 4. So when it's a negative number, I have to be in quadrant 4. Instead of positive pi over 4, it's negative pi over 4. When does tangent equal 0? That's at 0. When does arctan or inverse tangent equal radical 3? We said, according to my picture, it was pi over 3. When it's negative, that has to be quadrant 4. Well, just turns into be negative pi over 3. It's not that hard. Inverse sine, inverse tangent is so easy. And then this last one's a little bit weird. What the heck is undefined? So when does tangent equal undefined? It will be at pi over 2. Not negative pi over 2. We only use the positive. That's because tangent of pi over 2 is undefined. So it's kind of weird, but it does make sense. So what about the other 3 trig functions? Well, I have to use reciprocals. I have to think about reciprocals. So cosecant of an angle is 1 over sine. Secant of an angle is 1 over cosine. And tangent of an angle, cotangent of an angle is 1 over tangent. So what I'm going to do to determine some of these, inverse secant of 2, is there an easier way? Yes. I need to flip the function and flip the number inside the parentheses. I got to flip those both. I'm going to put this in pink. Do not flip the angle. The angle is what I'm looking for. Those don't get flipped upside down. The function and the angle. The function and the numbers get turned upside down. So instead of doing inverse secant of 2, I'm going to do inverse cosine of a half. If you notice, they both got flipped. And inverse cosine of a half is pi over 3. Okay? So inverse secant of 2 is really pi over 3. Now to do these, I'm just going to do arc cosine of negative a half. Well, because it's negative, I have to be in quadrant 2 now, so it's the same answer as before, but now it's 2 pi over 3. This one will be arc sine of a half, which is in quadrant 1, and arc sine of a half is pi over 6. Well, this one says inverse sine. I got to flip that number, I get a half. Well, arc sine and inverse sine are the same thing, so this again is pi over 6. For this one, I have to do inverse tangent of 1 over radical 3 or radical 3 over 3. They're the same number. And that is pi over 6, because that's in quadrant 1 as a positive value. I'm going to do arc tangent of negative 1 over radical 3. But now, because it's negative, I'm in quadrant 4. And quadrant 4 is the same answer as quadrant 1, is just going to be negative. Negative pi over 6. And it says arc cotangent of 0. Well, 0 is 0 over 1. So when I flip this, I get arc tangent of 1 over 0. Or when is it undefined? And we just said on the last page that is pi over 2. So here's my summary of quadrant 1 and quadrant 4 on how I'm going to use inverse sine, inverse tangent, inverse cosecant. In quadrant 1 and quadrant 2, I use inverse cosine, inverse secant, and inverse cotangent. We went through some examples. And then we have this big giant unit circle that we use for homework. And let's talk about this. It has the x and the y values, the sines and the cosines. Cosines and the sines. It has the tangents and this and that. And it has all 4 quadrants. But let's look at these quadrants. Here's quadrant 1, which is always going to be pi over d. Here's quadrant 2, which is always going to be n pi over d, where n is 1 less than the numerator. Here's quadrant 4, which is always going to be negative pi over d. So all these angles here are bad angles. That's not the angles I want. Those are the angles on the unit circle. The angles I want for the inverse trig unit circle are going to be negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. And then finally, quadrant 3, I don't use this at all. Okay, so this is a picture I'm using to do inverse trigonometry.